Dear students, in this video we are going to discuss about exercise numerical 2.25. It is a capacitor based problem and they are asking you to find the equivalent capacitance of the network shown in figure 2.35, and they are also asking to find the charge across each capacitor and also the voltage. See the general mistake done by students when they see this problem. Say they will just think this 200 picofarad. These two capacitors are in series. Then this one and all these three in parallel. So this is the the first look when you look at this problem. So this is what a general conclusion student make, but which is not correct. So what we have to do is, so we have to redraw the given circuit. So circuits are basically given in this manner just to confuse us. So we have to redraw the diagram, then it is easy for us to get the answer. So what we have to do is we have to travel from the positive of the battery. So we are coming here, and then here it is just getting split. So it means these two are parallel. So one network coming here, so 200 picofarad capacitors, and another one is 100 picofarad capacitors, and just it's coming here. So these two are joining. Then you have another 100 picofarad capacitor that is connected in series. Then the circuit ends. So this is how you have to travel. Let me redraw the entire diagram. See, now you can see the redrawn network. See, from the positive of the battery, so the two capacitors C2 and C3 which you are seeing here, those two are in series only. So but the same time, so one more parallel route is going for capacitor C1 which is in parallel. So this is C1 and they both join together. So this junction join together. After that you have capacitor C4, then the other end of C4 is connected to negative terminal of the battery. So this is the redrawn network. Now I think it's very easy. If you see this network, I think you can solve the question very easily. See, this C2 and C3 are in series combination. So you know the capacitance values are 200 picofarad. So C2 and C3 in series combination. So 1 by C of 23 is equal to 1 by C2 plus 1 by C3. So 1 by 200 plus 1 by 200, which is equal to 2 by 200. This is 1 by C23. So C23 is equal to 200 by 2, which is 100 picofarad. Or you can just do this easily because they are identical capacitors in series. It's C by N that way also you can do, or product by sum. So you can choose those easy ways also. So C23 is 100 picofarad. Then C23 and C1 are in parallel. Parallel, it's very easy. So C123 is equal to C23 plus C1. So direct sum we have to. So 100 picofarad plus 100 picofarad. So C123 becomes 200 picofarad. Now the C123 and C4. C123 C123 and C4 in series. So 1 by C1234 is equal to 1 by C123 plus 1 by C4. Yes. So again, it's one is 200 and another one is 100. C4 is 100. So I will write 1 by C effective, or C total also you can write C total, C effective. So 1 by C123 is 200 plus 1 by 100. So here a reciprocal sum you have to do. So you can take LCM 1 plus 2 is 1 by C effective. So C effective is equal to 200 by 3 picofarad. Or here also, if you want, you can go for the shortcut product by sum. So whatever, so C effective is coming 200 by 3 picofarad. So this is the effective capacitance of the network. And now we will find the charge, total charge we will find first. So for total charge, it is, we know the general formula, Q is equal to CV. So for finding total charge, you are going for the C effective, multiplying with V. We know potential is 300 volt, 300. So and effective capacitance is 200 by 3 pico, 10 power minus 12. So you can cancel whatever items that you can cancel. So you can write 20, so 3 zeros you can 10 power minus 9 coulomb. So you can write 20 nano coulomb. So this is the total charge that is going into this combination. See, now we want to find charge and potential across each capacitor. So the total charge we found, which is 20 nano coulomb. So I have drawn the circuit again. So we know in series combination charge remains same. So across C123 and across C4 the charge will be same. So directly across C4 you can write the same charge, which is 20 nano coulomb. So 20 nano coulomb will be here, and 20 nano coulomb will be here across C123 also. Okay, see, but we know in parallel combination charges will split. So C1 will have one charge, and C2 and C3 will have another charge. Let's before that, let's find the potential V4 and V123. So to find V4, so V4 is equal to, so we know Q is equal to CV. So V is equal to Q by C. So Q by C4. So Q is the total Q only. So 20 nano coulomb, 20 into 10 power minus 9. And C4 we know, which is 100 picofarad. So 100 into 10 power minus 12. So if you solve this, you'll get the answer. So if you cancel everything, so you'll get V4 is equal to 200 volt. So you'll be getting 200 volt here. So without even calculating, you can say, oh, V123. Can you guess what will be V123? Yes, you are correct. So it will be 100 volt, because the sum of the two potentials has to be 300 equal to the total. So V1, if you want, you can cross check. So V123 is equal to again Q by C123. So Q is equal to again 20 nano coulomb by C123 is 200, right? So 200 into 10 power minus 12. So you are getting the same answer. So 100 volt will be across the capacitor C123, meaning so we know in parallel combination potential remains same. So C1 also will get the same potential. C2, C3 together will get the same potential, but C2 and C3 individually, because here there is a voltage split. So V2, V3. So here again you can apply shortcut. So 100 volt, they both are equal capacitance. So equal capacitance, you can give the voltage also equal share. So C2 will have 50 volt, and C3 will have 50 volt. Okay, so C2 will have 50 volt. If you want, you can calculate also, or simply because they are identical, C2 and C3 are identical, so voltage will split equally across C2 and C3. So it will be 50-50, and across C1 it will be 100, here. So across C4 it will be 200 here. So put together it is 300. So we have found potential across each capacitors by concluding C1 it is 100 volt, and C2 it is 50, C3 it is 50, and C4 it will be 200 volt. Now we want to find the charge. Already C4 is found, it is the total charge 20 nano coulomb. So charge across, we will find a charge across capacitor 1, charge across C1. So Q1, so Q1 means C1 V1. So C1 we know, which is 100 picofarad into V1 is 100 volt. So it will be 1 into 10 power minus 8 coulomb, or you can say 10 nano coulomb. So we saw the total charge was 20 nano coulomb. So across C1, you are having a charge of 10 nano coulomb. So across C2 and C3, you need not calculate, because 20 minus 20 nano coulomb minus 10, so it will be 10 nano coulomb. You can even calculate and get the same answer, or otherwise, so across C2 and C3, because C2 and C3 are in series, so we'll have the same charge. So it will also be 10 nano coulomb. So total is 20 nano coulomb. Across C1 it is getting split 10 nano coulomb, and across C2 and C3 it will be 10 nano coulomb. Or if you want, you can go for the normal calculation also, C2 V2, so you can calculate, by which also you will get the same answer. So students, finally to conclude, so across C1 the potential is 100 volt and the charge will be 10 nano coulomb, and C2 and C3 also 10 nano coulomb, and across C4 it will be 20 nano coulomb, because it is in the main series network. And potential, so C1 is 100, C2 is 50, C3 is 50, and C4 is 200 volt. So this is the answer for the given question, exercise question 2.25. So maybe in exam they may not ask everything, they may ask only a particular thing. So if you answer that part alone, it will be fine. But for understanding, so here we are finding everything. One exercise problem is given in which everything we are calculating. So I hope it will be very useful, by which you can solve even competitive exam. One part of this question may even come as a competitive exam. So if you know the concept very well, you can answer any question easily. All the best. Thank you, children. Finally, so don't forget to subscribe my channel. You can subscribe and see the description box. I have given link to the other videos of other lessons, also some videos of 11th standard, which you can see. I hope it will be very helpful. Thank you.